Welcome back. In this video, we'll talk about prime factorizations and how they can help us find the GCD and the LCM of two numbers. Suppose that we have a number a that's written as p1 to the e1, p2 to the e2, pk to the ek, and a number b that's written as p1 to the f1 times p2 to the f2 times pk to the fk. And again, in this situation, ei and fi might be 0. Then the greatest common divisors of a and b can be written as p1 to the minimum of e1 and f1, p2 to the minimum of e2 and f2, times pk to the minimum of ek and fk, and the least common multiple is what happens when you take p1 to the maximum of e1 and f1, p2 to the maximum of e2 and f2, times times p sub k to the max of ek and fk. We can write those in product notation here. As an example, let 60 be equal to 2 squared times 3 to the first times 5 to the first, and 490 is 2 to the first times 5 to the first times 7 squared. There are some primes hidden here. We can put a 3 to the 0 in here and a 7 to the 0 here. We're just multiplying by 1. But now we have expressions that are of the form that we have above. 2 to some power times 3 to some power times 5 to some power times 7 to some power. If we want to find the GCD of these numbers, where it looks like I have a typo here, this should be 490, then to do that, we need to look at the exponents of each of these pairs. The exponent of 2, the minimum of 1 and 2 is 1, and the maximum is 2. Of the numbers 1 and 0, the minimum is 0, the maximum is 1. Of 1 and 1, 1 and 1 are the same, so the minimum is 1 and the maximum is 1. And of 0 and 2, the minimum is 0 and the maximum is 2. Now we just multiply these values together. We see that 2 to the first times 1 times 5 to the first times 1 is equal to 10. And if we multiply these numbers together, we get 2940. An amazing part about the GCD and the LCM is that when we take the number a and b and we multiply them together, 60 times 490, and if we take the GCD and the LCM of a and b and we multiply those together, 10 times 2940, we get the same answer. They both give us 29,400. This isn't a fluke. We can actually prove this using the same framework of prime factorization. We first recognize that if you have any two numbers, x and y, the minimum of x and y plus the maximum of x and y is always equal to x plus y. And we can see that because if x is less than or equal to y, then the minimum of x and y is x, the maximum of x and y is y, so we get x plus y. But if on the other hand x is greater than y, then the minimum of x and y is y, and the maximum of x and y is x. And so we get y plus x, but that is the same as x plus y. Let's use this fact to prove that the GCD of a and b times the LCM of a and b is equal to a times b. Here we go. The GCD of a and b, we said on the previous page, is equal to the product of pi to the minimum of ei and fi, whereas the LCM is equal to the product, from I goes from 1 up to k, of p sub I to the maximum of ei and fi. Now we can bring those products together. When we multiply a number to a power with the same number to a different power, we then add those two powers together. And so we get the product of pi to the minimum of ei and fi plus the maximum of ei and fi. Now, this is where we use our key fact above, which says that if we're adding the minimum of two numbers and the maximum of the same two numbers, we actually get just the sum of those two numbers. This second product is equal to this third product, the product of pi to the sum of ei and fi. Now we can break this product apart. This first product is exactly a, the second product is exactly b, and so this equality shows us that the product of the GCD of a and b times the LCM of a and b is equal to a times b. How about that? All right, we'll talk to you next time. Take care.